no longer good morning, good day. I hope you're enjoying your lunch while we're diving into how to achieve digital severity with tech stack liquidity and some automation tools around there. Who am I? I'm Merlin. I'm staff software engineer with Moderne. We are behind the tool OpenRewrite and helping teams to migrate their software on a bigger level to new and up-to-date versions. First of all, I want to start with a poll. So who of you have carried out a framework migration into production ever? Quite. Not nearly the half, 1/3, 1/4. It's kind of explains why there are so many outdated software available and why we are blocked by, as an industry, blocked by so many technical debt here. Let's come with me to dive into it and how to overcome that, because this technical debt is blocking us on every level. But why is technical debt and how it is connect to digital severity, and why do we want to achieve digital severity in the first place? Digital severity, apart from the political loaded term, basically means that you have technical independence. You're technical independent to choose how you want to develop your application and bring your application to production. One very common example that is slightly out of date, but very common, is the Java EE stack, where nowadays there's mostly a commercial JVM underneath and then commercial, probably outdated application server. There's nothing wrong in terms of software engineering with this stack. And I don't want to dive into Java EE with Spring with Quarkus discussion here. I just want to point out that this stack is very common, but it's getting more and more costful and more insecure. Why is it costful? Because big players raise the license fees to allow you to still run on Java 8 or Java 11 in the near future, run on very outdated application servers. Then there's this end-of-life problem. For example, with Spring or with Java EE, nobody want to build on Java EE anymore, so there are no new products on Java EE anymore. It's basically end of life. And you have the vendor lock-in. With old software that only one vendor provides your service with, provides your updates with, you're locked to this one vendor. And when the vendor decides to, let's raise the money, let's raise the price because you want to earn more money, you are trapped in there and have you don't have the freedom to say, okay, screw you, I go with the other guys. And then there have you the security debt, the security problem. We have a security problem because the vendors of these big, outdated software constructs usually tend to have longer response times than an up-to-date software project. You can see this in license fees increasing, dying application servers, security fixes being around, known CVEs being around in old software for years and months. So we need digital severity, as it means freedom, to become digital independent in our decisions again, to be able to move from whatever to whatever. To achieve this digital severity, we need to have something that is called tech stack liquidity. Tech stack liquidity is the property of an organization to move between libraries and to roll back historically decisions when requirements change. For example, Spring Boot upgrades, time changes, end of life. Do you have the freedom to quickly move to a new Spring Boot upgrade? Probably not, because you're stuck on an older JVM, because you're not able to upgrade to Java 17. Therefore, you're not able to upgrade to Spring Boot. You also have a big number of outdated libraries. Do you remember Log4Shell? That probably will happen again. It's not uncommon. How fast are you able to move between your vulnerable custom development based on Apache logging or Java util logging. You don't have the freedom there to move that fast. So the automation automation here is kind of key, because we have a very nasty cycle. We are all in there. We have the business that is pushing for more and more features. Therefore, we are focusing on the features, building up tech debt. This tech debt hides or introduces security debts. And so we are always in this emergency mode, and we are definitely losing quality here. That's an old story. The tech stack liquidity breaks the circle because you are able to develop features and get rid of tech debts, critical security debts, security issues, and be able to get out of the security mode where you're just reacting to a situation where you are driving the change. You are knowing what's in front of you, and you are able to break there. This is just a technical problem. So being up to date is, of course, one of the solutions. Automation can help there to even be faster in migrating there. But we have also another problem, mathematical problem here. Because if you just focus on one project, it is already a lot of resource consuming to migrate from Log4j or Spring or whatever. When you have a lot of repositories, 20, 50, or if you use a lot of frameworks, you end up in a combinatorial complexity here. And we are not taking into account here that we are using different versions of the frameworks, different teams with different cultures using different API styles of the same dependency, and so on and so forth. So, do you know how many repositories your organization currently is dealing with? Approximate? A lot. So I think for most of us it's a valid answer to say a lot. Do you know how they are moving in terms of framework migrations at all?
Depends on the project.
Depends on the project is in...
So some are moving really quickly, some are moving, don't move at all.
So I don't think that upper management will like this answer at all, because it's not plannable. There's no plan there. Even if there's a roadmap, this roadmap usually takes years to apply. Not great for security fixes and updates. Or if you're just fixing security stuff, then you're building up, again, another big mountain of technical debts. Or, yeah, we have defined standards is another possible answer there. We all know what's happening with standards. It's worked around there. But we have another pressing point, a pain point here. Not only the technical debt that we are dealing with, we have something that our executives are dealing with. We have something called post-quantum cryptography. Anybody aware of the post-quantum cryptography problem? There was a talk about it yesterday, I think. Post-quantum is the problem that our at the moment stable and secure algorithms and techniques to decrypt stuff and to hide stuff from whoever, are too weak when approached with a quantum computer. And the problem is that it is already happening. So there are already standards to guard against there since 2024. There's the US government. You have 25, the German government, which is usually one of the slower governments, to be honest. I'm German, I'm allowed to say so. And the EU is expected for the 2030. And quantum computers at the moment, 35 to 45. But I'm a little bit pessimistic here, not on the technology speed, but on the publicity. I don't think that most parties will make it public once they are able to break encryption algorithms. Because there's a huge interest in stealing information now, encrypted information. Now they are safe. But let them rest for 10 years. They are getting better. And once we have the encryption algorithms there in place to decrypt them.
Doesn't IBM already have a public cloud computing service?
Yes. It's not capable of breaking yet. But as I said, it's happening now. So this post-quantum problem, again, moves this on a business level from, yeah, it's nice to be able to shrink the amount of technical depths and move to modern software, so we are more appealing to younger developers and stuff. It makes it business critical because I cannot imagine the big burst that will happen when one vulnerable database, like banks, insurance companies, governments, will be decrypted. So what is the possible solution here that I am opposing here? It is automation and automation of migration, and therefore there's OpenRewrite. Let's dive a little bit into OpenRewrite first, because before we see some demos there. First of all, OpenRewrite is a tool for massive scaling factory code changes. It was originally founded in the context of Netflix. It's not a Netflix product, but it was founded in the context of Netflix, when one of our founders, Jonathan Snyder, had the task to migrate from an internal logging framework to SLF4J. You might see a point here that you probably have the same problem in your case. It is very, very erroneous, because there are different versions of this logging framework used overall. There are different API adoptions, different way of loggings, and all of that has to be migrated to one standardized way for log4j. Therefore, they came up with a tooling that is able to read the code like we do with all the internals that are of interest when you're dealing with semantical changes, and define some migration rules there. These rules are named recipes to move your code from one side to another. Let's dive a little bit into what's the secret sauce here. First of all, we have this text-based representation of source code. This text-based representation of source code is for humans and for humans only. It encodes a lot of common knowledge. A common knowledge about variable names, comments, intentions, used coding styles, patterns, and all of these are contributing to our understanding of the source code. And everything of that is contributing to our decision what to do when we have a migration at hand. There's a second very common representation of source code. It's the AST, the abstract syntax tree. It's the secret source of compilers and interpreters, as you know. The problem is this is an optimized representation for execution. There are no comments, no type names, no variable names, no type information, because it's not needed to execute a program. But it is needed to migrate a program, a source code from 1 to B. Therefore, we have this lossless semantic tree. You might see that here are blue dots. This is the AST. It is embedded in the lossless semantic tree and enriched with generic type information, comments, intentions, all the things around there that are interesting for us to understand the code. With this LST, when you alter this LST, you can derive back the code, the changed code. And the changed code only changed in these locations where the real change happened. So we will have a very minimal change, and it is deterministic because it is rule-based. A big plus about a lot. I said it is an open source tool. Yes, OpenRewrite is an open source tool, and it will stay. It's Apache license. We have a look later there. And we have already a bunch of recipes available. There's 4,000. I need to correct the slide. It's 1 month old. It needs to be nearly 5,000 recipes now. Most of them are open sourced. Most of them are Apache licensed, even though especially the very small atomic building blocks like changing a method name, adding a private static final stuff there, renaming a variable, adding, removing a dependency, and updating. And then we have the modern preparatory recipes. these are only available for customers. These are the very, very high value recipes that our engineers are writing to have a first day migration. And then there's this part in between, the modern source available license. These are also applicable for everybody on everywhere on their own code. And these are outdated recipes that we re-implemented or redevelop in collaboration with the open source community, or that are not that high of value. You see a lot of examples there as well. Just to be sure, modern proprietary license recipes are making only 5% of all recipes. So you're good to go with 95% of all recipes. Should be good for most organizations and smaller ones especially. What does the recipe do? A recipe changes code. Here we have a migration for JUnit 5, 4 to 5. It's not easy to not direct to see the connection to digital severity, but it's a good example of how you can migrate complexer applications across multiple versions here. We also have one for JUnit 6. We need to upgrade the slides here. It's doing a lot of code changes there. For example, the assertion that a certain exception is expected is moved into the body. And that is a very complex code change because you have the exception up there in the annotation. It needs to move into the method body. There need to be new method invocations imposed. So it looks like a simple thing, but it is basically a very complex thing to get right. And now imagine this is only one test, and I hope you have a way better test coverage than just one test, and it's repetitive all over. I talked a little bit about the OpenRewrite stuff. The OpenRewrite stuff is open source and will stay, and it's because it is Apache licensed, it is reused in different projects here. First of all, OpenRewrite has the Maven and Gradle plugin, integration free to use. We don't use that today because it is a little bit slower than the things we will use. But OpenRewrite is also contained in GitHub Copilot, Amazon QTransform. IntelliJ can execute OpenRewrite recipes, Broadcom Application Advisor, and IBM Watson. All of these tools are relying on the OpenRewrite core technology here. So it seems to be a very, very decent choice. But OpenRewrite has one problem. It is focusing on one repository, which is great for small teams, for individual developers. But when you want to attack something like a Spring Boot upgrade or logger harmonization across your whole organization, running the same recipe again and again and again and again, 100 times on different repositories, or running the same recipe repetitively to catch your not yet mentally migrated engineers, then it comes a little bit inefficient. Not a little bit, it is, you can write a number on it, because every time the OpenRewrite integration executes a recipe, it is roughly your build time plus roughly 10% of execution time. If you take into account what some of your projects have in cumulated build time, including building tests, this is quite an amount. With the OpenRewrite and with the Moderne tooling back there, we're setting enterprise tooling on top of that. The secret sauce here is that Moderne tooling is able to store the LST, create the LST up front, and every time in the platform or an engineer needs one of these LST, it's on the shelf, pick it, run a recipe. Recipe runtime is down to a few seconds. That's why we, in the upcoming demo, will use the public available app tenant, which is the software as a service solution. Know that there's no special kind of OpenRewrite built in there. It's the core OpenRewrite. You will receive the same results with the OpenRewrite tooling. You just have to wait a few minutes more. So what are we attacking in terms of digital severity with OpenRewrite tooling is that we have the ability to be vendor independent. So we can move from one vendor to the other. We can move from Spring to Quarkus. We can move from one logging implementation of SLF4j to another one. We have security agility. We can close CVEs easily because we can make sure that across the whole organization, this one vulnerable dependency is exchanged with the fixed one. No longer writing emails, talking to people directly. Do you think you use this vulnerable dependency? Yes? No? I don't know? Most time the answer is I don't know, to my feeling. We are future-proofing ourselves here because once we are on the latest version of a framework, it is easier to adapt the next big step. You can see that in Spring Boot. The upcoming Spring Boot release, the 3.6 release, is in preparation release for the bigger one, 4.0. If you apply every step in the migration guide from the Spring Boot 3.6, the migration to 4.0 will not be that hard for you. And you have a cost control. That's more a point for your managers. When you have reduced dependencies and reduced problems there, you have less time spent, less resources spent catching up, fixing CVEs, understanding stuff there. For now, if there are no questions at the moment, I would stop the thing here and jump to the app tenant here for a little bit of demo so that you get a feeling of how does it feel to execute your recipes. Know that you're free to use app.moderne.io, so everybody can. Only restriction is you need a GitHub, GitLab, or Bitbucket account because we need to know who you are to verify that you're allowed to access certain open source repositories or closed source repositories. We are not storing any data about you besides that you have logged in. Then we have nearly 40,000 open source projects ingested. Oh, thanks for noticing. I still try to get used to the new MacBook default setup. Again, nearly 5,000 recipes ingested there. Most of them are open source, and all of them are okay to use on open source projects. The nearly 40,000 projects there are for you to play around with. These are a selection of open source projects that we also use to test our open source recipes. So we are executing every open source recipe against this whole bunch of repositories to find new edge cases and to harden the recipes further. You can also see that we have, I just zoom in out a little bit. You see a lot of familiar icons there. So it's not only Java. Yes, we are rooted in the Java world. We support nearly everything that is surrounding the Java technology in terms of infrastructure, configuration, and so. Let's now run a recipe, and let's start with the most pressing one from my perspective, or because we are a Spring Boot shop, so Spring Boot is the most pressing one for us, and probably the most pressing one for most of the development world. If you're looking at the at the market shares, I have selected the recipe. I have seen the details there. I know the details, but I have hit dry run. Dry run is an action to execute the recipe on all of these repositories that are selected. I have selected Netflix and Spring. This is an augmented group of repositories containing Spring projects and Netflix open source projects, platform projects, and quick start projects. So you see the difference there, here and there. And we have executed the Spring Boot 3.5 recipe. That's why we are adding here missing Gradle configuration to use the JUnit platform. Obviously, someone migrated this project by hand and forgot to add the Gradle configuration to use the JUnit platform here. I don't know how this is working in the first place, but it is. For example, Nebula testing here, same thing here. We're removing some JUnit stuff here and adding the configuration here. Because Spring Boot 3.0 required a Java 17 upgrade, we are doing some Java 17 upgrades here. And not only you have to do these things, we do a lot of best practices and recommendations from the Java and Spring Boot core teams as well, like deprecations, in this case pattern matching. We apply string manipulations here, for example, from string.format to the postfixed version, the formatted version here. There are also recipes to collapse the dot and create things there. I will cancel the recipe run once because otherwise the platform will be busy all day. Not all day, but if everybody runs a demo and not stopping the runners, then will not help. What you see here, we have 2 minutes of recipe runs. We have nearly 100 repositories with changes now, and approximately 100 hours of saved time. So that's the time that engineers estimatedly would need to do these changes manually. So with this recipe run of 2 minutes, we have moved them to moved all the projects to newer versions, can open PRs for them, and enable them to reduce costs by stop paying Broadcom ridiculous high values on support costs, and being able to move from a legacy Java 8 to Java 17, Java 21. And from there on, with Spring Boot 3.5 now, they're free to choose any newer deployment models, no longer old-style application servers. They can adopt cloud-provided stuff as well. One other very interesting use case that I already pinched here is I have to change the repositories here because this is another one. We don't want to run this. We just select this. It's the post-quantum cryptography stuff. This recipe is a little bit different, but it shows quite nice what's the capability of OpenRewrite and Moderne on the enterprise level. For post-quantum cryptography, it is important to know what will be a problem in the future. So where do we have to do changes to be secure? The problem is that at the moment, it's not 100% sure what will be the solution. But it's important to know right now, where do we need a solution? For this, there's the post-quantum cryptography recipe that is looking for hard-coded, weak encryption algorithm, hard-coded secrets, and so on. And here we see that we have no code change. It is yellow. Yellow always means here's a search result. So we have used this recipe to create a query, to execute a query against our code base to find every place. For example, we can have a look here. Why is this found? It is a hard-coded algorithm choice, which is bad because you cannot act fast there. You have to rebuild, redeploy. You cannot change in configuration and have another encryption algorithm, a post-quantum stable version. For the next use case, I would quickly show you the builder feature we have, because when you have different logging libraries, private ones, old ones, you want to harmonize them usually at some point. You want to roll back your old decisions to use Java util logging, to use log4j or JBoss logging, to one centralized decision here. In this case, I have created a recipe consisting of other recipes to migrate from Java util logging, from log4j, from JBoss logging, from JBoss logging, log4j4 to SLF4j, and apply the best practices for SLF4j here. If we have another custom recipe created for our own logging framework there, We can put that here as well and quickly run a dry run again and get results on, that's the wrong organization, quickly cancel this and jump over. These are pre-runs because sometimes a colleague in the US decides, oh, it's morning, time to deploy a bug fix. So it's good to have them pre-run. Here we have the results from this exact same recipe run. We see that if you're going from log4j to slf4j, of course you have to change the imports. You have to change the way how you're creating in logger context or in logger, how you're getting the logger to set the level, how to get the logger again in different files. Interestingly, for log4j to slf4j, it's not that much to change. Here we have a best practices stuff where we have a string that is inserted with values. So this is the best practice stuff. So this recipe here not only moves you to the same logging library, it also has the ability to streamline this usage again. So that you have a common usage of the same library, which again is very helpful when you're considering switching between projects there. And these recipes qualify as recipes to be executed again, especially the best practices ones, again and again, because the muscle memory of engineers is existent. They will keep writing old style code after this migration is done. They don't want to, but they will. And to help them to fix up, to not again build this tremendous amount of technical debt, you can rerun this recipe again and again and again to get them keep them up to date. Let us jump back, and I just scroll to the right thing. So we have seen a Spring Boot migration. I like that a lot. We have seen logging stack consolidation, so moving to one consolidated way there. We have seen how we have not seen a solution for post-quantum cryptography, but we have seen a way to get an understanding what will be a problem in the near future. With that, let's wrap up real quick. We have time for questions then, or you head out for another coffee and we have a meeting at the booth. I'm there rest of the day. So I would make sure that you take a few things with you, that tech stack liquidity is a measurable value for your organization to measure one step further to digital severity. Also, automation is in place. There is automation to move you between different versions, different styles of using. Please be aware that these recipes are the cumulative knowledge of engineers and the open source project. And these rules are deterministic, means that there are a huge amount of migrations being able out of the box. But there will always be cases where you need manual manipulations because you see from the n times m problem, there are different libraries we haven't seen yet. There are different APIs that we haven't seen yet in combination to that. Then please take it with you. It's not the main point of this talk, but I find it very, very, very important that we all take this with us, that post-quantum cryptography is a thing here, and that we, as software engineers, will get back to post-quantum and the migrations imposed by post-quantum. Anti-automation will speed you up, definitely. I'm very sure there. Even though it is, in the beginning it doesn't feel like this, but in some it will. So where you can learn more? Of course, we have documentations for OpenRewrite, docs.openrewrite.org. It is the cumulative knowledge of all recipes, how to apply them, which version apply, so everything you need to know to get started with OpenRewrite. With Moderne AI, we have our tooling, and there is references to how to do that on a bigger level, on an enterprise level, how to get started there. Play around with app.moderne to get an understanding which recipes are available, which results are about to check, you will see. Or if you want to have your own migration in mind, we have an open source project. We are an open source project. GitHub OpenRewrite.org is the open source community there. Join us, write a recipe. We are happy to help. My colleague Tim and I will be stepping in instantly with you. Or see us on YouTube every Wednesday when we're talking with community leads and different people from the Java world about what's migrating, what to migrate, what's upcoming challenges here. For now, we have 4 minutes left for questions. Thanks for staying with me and over the lunch break. I hope you will have another 2 awesome days of DevVox. Under mboogie.dev, there's the slides already available. And on the left, there is the link to our free training courses, how to get started with OpenRewrite, how to write recipes, and how to dive into the advanced features of OpenRewrite. So, are there any questions? Yes?
Thank you for the presentation. 2 questions. One is it possible to write our own recipes? And second, do you have recipes to move from one language to another?
So, the first question was, is it possible to write your own recipes? Yes, of course. It's an open source project. The API, the core is Apache licensed. Most of the recipes are Apache licensed. We even have a GitHub template available for you so that you can copy. This is already pre-configured for Maven and Gradle, where you can write your own recipes. You can keep them internally or open source them. It's open. It's Apache licensed. So yes, if you want to learn how, OpenRewrite Training Hub every 2 months for our workshop to get started with recipe authorship there. For the second one, language-to-language transformation, it depends how you define language, from which language to which. From one Turing-complete programming language to another Turing-complete programming language is, from a mathematical perspective, doable. But we don't do this because we think there are enough tools out there that do this. We pick you up once you're in one language. For not programming languages like YAML, XML, or stuff, we have that one. So you can move your GitHub actions to GitLab runner configurations, or your property-based file configuration to XML or YAML or Java-based configuration. So that's possible, but we don't focus on Java to Kotlin, COBOL to JavaScript or whatever, because the problem space is huge enough. Yeah.
How do you do with Git repositories of big companies? How integration passes for your...
I don't have the architecture here in these slides, but they are publicly available under docs.moderne.io, how this is done. In a speed run, there is an ingestion process that is producing the LSTs on your end, pushing the LSTs in your internal Artifactory. There's one component called Moderne Agent, has nothing to do with the coding agents or stuff. It's basically a proxy that is dealing with ingress encryption. When the Moderne SAS is requesting, has to run a recipe on a certain repository, it calls in there, gets the encrypted LST in memory. When it has to decrypt this LST to run a recipe on that, it also gets the key from your environment, decrypts it, forgets the key, runs the recipe, forgets the LST, and sends back the patch file. So no data is at rest at Moderne. It's all on your side at rest, and you're in charge of the encryption and the keys.
In any case, you don't have the access to the source code?
we need the access to the Git sources, at least in the ingestion process, because somewhere we need to clone the resources there. No further questions. I think we made it 13 seconds. Yes, last one. Then we had to head to the booth.
How easy is it to start playing with it in already established projects? So Java project 10 years old, how easy is it to start converting?
docs.openrewrite.org, recipes. There's a search bar. For example, migrate to Java 25. This is a recipe. And then you have the usage here. Copy the Maven integration, hit run, done. Same for Gradle. So the barriers are very low on intention. So any further question? I would like to have a coffee with you. We can meet at the booth. We are there all day, and we are all day in the hallway as well. So thanks for staying with me. See you at the conference. Bye.